Okay, so I'm gonna be pretty heavy on highlighters here because have at least two, if not more. So on Friday, if you can remember what happened on Friday, right? I gave you a bunch of keywords that are on page 48 that are going to guide us when we are writing inequalities. We're producing the inequalities for word problems. So every time for like I would say they're really good to have on your study sheet. Really good to have on your study sheet. Maybe we should add that. But here we go. So we start simple. We're going to build, and eventually we're going to come up with a system and graph it. Okay, so that's what we're ultimately after. So X were the number of people, Y number of pets. It's very important that you define your variables. Like, what is it that we're talking about? And then anything else I throw at you, right, you can work with it. We were told, right, a scenario where we weren't allowed to have no more than 400 people, right, in the building. So this is how you would make that statement, because we're coming up with a restriction. We're saying that anything above it is going to make this thing false, right? And then the next one, a dog park could hold up to 45 dogs. It's specifically to dogs. It's not talking about people here. So we said, okay, well, Y is less than or equal to 45. That would make this restriction happen. Okay. And then we had a dog park can have 100 dogs and owners combined. Okay. Emphasis on the combined. And we have both variables, X and Y, represented here. Okay. Next, a vet can see up to 24 pets per day. And so pets obviously would be under the dog category. So we would go Y can see up to 24. So that has to be less than or equal to 24. The number of dogs in this case would have to be less than or equal to 24 in that case. So I did use like pets, I'm referring to dogs in this case. A committee needs at least 5 members. Okay. And obviously in this case, context would imply that this refers to people, right? So people would be the X variable. When it says at least, what's our key? What does our keywords would say here? Let's go peek in 48 real quick. When it's at least, you want greater than or equal to. So the number of people in the committee has to be greater than or equal to 5. Okay, there's that. A stadium allows up to 20,000 visitors and pets combined. I was like envisioning like Caesar Milan coming to a stadium and doing a big show or something like that. So 20,000 visitors and pets combined, right? So this is X and Y, right? So we would say the number of people plus the number of pets, that combination, right? You can only have up to 20,000. So this combination has to be less than or equal to 20,000, like that. So this is, when it comes to context, this is what you can expect. Sometimes specifically just to one variable, and other times it's combined. It's talking to both variables. Okay. I'm going to let you try this one here. Well, it says two numbers have the sum that is less than 20. It's kind of a bit of a riddle. How about we let's define our variables. Let X be the first number and Y be the second number. So how would you come up with the inequalities based on what you read there? Could you come up with, read it and see what is the system that you would have to set up to find possible solutions for this one here? Give it a try. Just read it, see what you come up with. Okay, I'll just do my attendance and I'll be back. I'll take it over here. Two numbers have a sum that is less than 20. So we already identified our variables. This would be discrete or continuous. It could be anything. It could be any, like, it doesn't have to be whole numbers, right? So continuous data. Okay, just making an observation there. So two numbers have a sum that is less than 20. So a sum, right, whatever the sum is, would have to be less than 20. Not less than or equal to, but just less than 20. So this would be, right, this would be an IQ, right, inequality number 1, so to speak. And then it says twice the first number plus 5 times the second number is at least 50. Okay. So you basically just follow the recipe, right? Twice the first number plus 5 times the second number is at least. So that whatever you plug in, when you go 2 times the first plus 5 times the second, that has to be greater than or equal to 50, the way it's worded, right? This is the second IQ. And this actually would span all 4 quadrants, okay? This is not a word problem where we restrict it to quadrant 1, right? Graph would span all 4 quadrants. All of these other ones up here that we did, they would be restricted to quadrant 1, which our word problems are gonna basically be restricted to. Okay. All right. Let's jump into a scenario where you have a word problem and you're going to develop a system, right, of inequalities. Let's go to 43. And here are the steps that are pretty much universal across the board in this unit. Okay. Steps to interpret, graph, then solve word problems, right? So I'm just going to highlight this box because it's very, very standard, and I've tested it against like all the problems that I assigned. I've always worked through them before. So the first step would be very important to introduce your variables, right? So let x be the first variable, y be the second variable. I really stick to x and y most of the time. Textbooks sometimes go with different variables. State the implicit constraint or restriction, and namely that x and y is greater than or equal to 0. I will sometimes ask for this specifically, but if I don't, you still write this down. Always state this, because this is basically telling us that x and y both have to be positive. Okay. Next, write the inequalities presented by the question. Each restriction should be represented by an inequality. Right? This is very important here. Each restriction should be represented by an inequality. How do you know there's a restriction? I would say look for keywords. Okay. Look for keywords. That's going to give it away. It's like, oh, there's a restriction here. Okay. Graph the inequalities in step 3, obviously. State all POIs, right? Round if discrete. and then state a possible solution found in the solution region. Sometimes the textbook, which I don't really use a whole lot, will refer to as the feasible region. And I think maybe a question or two in here will be the same. It's the same thing. We're talking about the solution region. Right? So these are the steps that I commonly follow, and they usually end up making it easier for you to set up and solve. So here we go. A certain manufacturer makes scarves and toques. It usually gives it away in the first statement what the variables are going to be. Scarves and toques. I'm already going to put an X there and a Y there, even though I will do it formally down later on. Then I'm given some information here. It takes 15 minutes to produce a scarf and 10 minutes to produce a toque. The company has up to 2 hours of production time to make that happen. Just in general, just has 2 hours of production time. Graph the solution set, state the POIs, and then give a possible solution. So I'm going to first say let X be scarves, but not just, you also want to identify the units, number of, okay? And then Y would be toques, and that's also number of. So we want to, those are the variables and that's what they represent. Step number one. Step number two, just go ahead and state this. X and Y, they both have to be greater than or equal to 0. I do check these, okay? I do check these, and please don't do this one. This is a common error. Because students just like slap something in there, it's like, and just keep going. Here you're saying X and Y, they both have to be negative, right? They have to be less than or equal to 0. This is an error, so don't do it that way, right? There's a mistake right there. Okay, now we're gonna go into the inequality writing piece. When you read this statement, is there any indication in that statement under this bullet that there's a restriction placed? Do you see any of the keywords we've talked about in that statement? Is there an up to, or has a capacity of, or anything like that? And the answer is no. It's just, they're just giving you some facts here, okay? When you read the second bullet here, it says the company has up to 2 hours of production, right, available. That, right, is an inequality right there. That's basically a restriction set, like it cannot spend more than 2 hours, okay? So in this particular case, you would have to say, well, we're talking about hours, right? And there was some indication, right, that's a time restriction, and there's the times given in minutes here. So there's a bit of a conversion that we need to do. But other than that, you'd have to write it this way. If it takes 15 minutes to produce a scarf, and you're also producing toques, so that would take 10 minutes to produce. That combination of time, whether you make 5 of these and 4 of those, 10 of these, 3 of those, it doesn't matter. This would give you the time that you spent on producing them. That has to be less than or equal to, let's just do that here. 2 hours is what in minutes? I think we can just do that real quick here. That has to be less than or equal to 120, like that. Okay, and this, so this has this inequality, right? That there's a restriction on time. So in this case, it's not a system, it's just one inequality. So I will go through the motions and do the same thing as I did before. Once you have an inequality, I find the intercepts, I rewrite it, and then I graph it. So let's go ahead and do that real quick. X-intercept would be 15x is equal to 120. I don't have the key in front of me right now, so that's Monday and I don't want to get it wrong. That's 8. That's 80. For y-intercept, 10y is equal to 120. The nice thing is, for word problems, you don't have to worry about the negative, the minus a negative y. That's usually with non-contextual problems. So this is 12, 0, 12. You've got your x and the y-intercept right there. Then we have the rewriting part. So 10y is less than or equal to negative 15x. Slow down, Mr. Dirksen. All right, I will. Plus 120. Then divide everything by 10. I must say, you're doing really good at not missing the last. Like, a lot of students only divide the first one, not the second term. You're doing really good there, so way to go. That's negative 1.5, and you go for it if you want that. Solid, true is where? Less than? It's below, right? True region is below, we're shading above. And you might say, but this is not a system, Mr. Dirksen, so why would we, I'm just going to stick with reverse shading from now on, basically, just to not mix you up too much, right? So because this is quadrant 1, you're restricted to quadrant 1. So this is no longer x and y. You want, this would be scarves. Scarves, number of. It won't always be number of. Sometimes it might be liters, right, or whatever. Fuel in liters. And then this would be toques, number of. And here's where you have to just come up with your own scale. In this case, it's not too bad. I'm just going to go up by 2's maybe. 2, 4, 6, 8, 10. Don't have to label every single one. Right? Just make sure I understand what your scale is. And then going up here, I need to go all the way to 12. So I'm going to go a little closer together. So 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12. That's good enough. That'll do the trick. Just make sure they're equally spaced out. On tests, I usually give a grid, but with word problems, I actually prefer to, I'm just going to give you the x and the y axis. You have to put in your scale. Okay? So 8 zeros right here. 0, 12 is right there. And for word problems, except for there's maybe 1 or 2 questions where you have to worry about the dashed line. Just go like this. 15x plus 10y is less than or equal to 120. That's this one. And I'm going to shade above. but the solution region is right here. Again, I'm most interested in the solution region. So whether you use regular or reverse, it's up to you. What is it asking us here? State the POIs. What would be the point of intersection in this case? They're actually very easy to find here. We actually know them already. But it is actually, we consider with word problems, X and Y are basically inequalities. It's as if we shaded everything below this and to the left of this with the initial statement here, this one right here. Okay, so it would be this one, and this one, those three POIs. So it'd be 0, 0, which seems very irrelevant, but that is a point of intersection. And 0, 12, as well as 8, 0. Those are the POIs in this case. And give a possible solution. Possible solution. You pick. The line is solid, so you could pick 8, 0, 0, 12. You can pick anything in here. So you could go 2, 2 if you want, right? Example, 2, 2. What does that mean? Producing 2 scarves and 2 toques. That would be one possible solution. 8, 0. Producing 8 scarves and no toques would also work. Yeah. However, as we get more difficult, as it gets kind of like amping up the difficulty level, there will be other restrictions here. There might have been one where you have to make at least 5 toques. So there would be a line right here, and you would shade everything below, so you're kind of restricted to just that little sliver up there. So it depends on the scenario that you're given. Okay. All right. Where am I? I'm going to give you a little bit of work time here. So I'm going to skip a few pages. I'm going to get you to go to 46. Oh, were you done copying? Well, just go to 46. I'll meet you there in a bit. And for now, I don't want you to graph. Like right now, I think the graphing, you're doing pretty good once you get everything else right, but it's writing the inequalities that we need to focus on. Okay, so I'm going to get you to go to 46. And there's only one inequality in each one of them. So it's not a whole lot of work that you need to do. But I want you to, for every single question, 46 and 47, okay, do 46 and 47 right now. I want you to, or am I doing that already here? Anyways, define variables. I want you to state the implicit constraint. Oops, I'm off script there. And write the inequality. Those 3 steps I want you to do for all of these questions here to the best of your abilities. Okay? Find the variables that are there. Write the implicit constraint. That one is easy. Implicit constraint is always x, comma, y greater than or equal to 0. It is every time. And then go ahead and write the inequalities, okay? Go for it. Have fun. Slips away. All right. Make sure you correct. There's gonna be little things that I'm gonna be picking on. Okay, little things that are important. So if you got the inequality right, that's good. But I'm gonna look at everything, right? So for the first one, we've got making motorcycles and bicycles. So I'm thinking number of, and why it would be bicycles. Number of. Okay. So, and some of you were unsure about this one, and let me tell you, it's just as simple as just saying before we didn't have to worry about this, right? Because we didn't have word problems. So now both x and y are greater than or equal to 0. So they're both positive. Okay, let's write that down one time here. Both variables are positive. And we're also saying quadrant 1 only. Okay, that's what we're saying with that implicit constraint. So we must include that to get this right. So in this case, it's just saying that the number of vehicles in a week, right? So talking about both variables has to be less than or equal to 400. That's it. I saw a lot of you doing this, getting this right. So it's important which way it's pointing, right? The inequality. Next, we want to spend 10 hours studying for math and science. So let X be. Some of you just went math and science, and there's nothing wrong with doing that, but you need to be a bit more specific. So it would be what? Hours, right? Hours and hours in this case. You can say minutes, but I'm going to stick with hours here. Okay? And so it's saying that the time spent studying for both of them, you want it to be up to 10, but no more, right? So you could spend less than 10 hours, but you only have 10 hours available. So that's what it is. So important thing here is that it's hours. This one is continuous. Would you agree? You can study a portion of an hour. So this one is continuous. Continuous data. Discrete. This one was discrete. I threw that in after, right? So whenever it's number of, discrete. If it's hours, liters, kilometers, anything like that, that's continuous. Anything you can measure. Okay. A dealer can purchase touring cycles for $300 each and racing cycles for $400 each. She plans to spend no more than $8,400. This one is a little different. Okay, so let's define first. X would be number of touring, and Y would be number of racing cycles, I should say. Okay, that's the implicit constraint is this, and we know that this is discrete. So we would round any points of intersection, but that's for later this week. Okay. So in this case, you need to say, well, if it's $300 for every touring cycle and $400 for every racing, that's my Y. That has to be less than or equal to 8,400. So it will affect my choices when it comes to purchasing. Okay, let's keep going. Some conversion required on this one. I always go from the greater unit to the smaller. So we know that 1 kilogram, I hope you know this, right, has 1,000 grams. So that turns out to be 2,250 grams. I'm converting that. X and Y. X would represent cake A, and this would be cake B, number of. Wouldn't you say? Oh, there's grams in there, Mr. Dirksen. I don't know. right? Earlier we had dollars, I don't know, but it was the number of bikes, right? So, and then it's xy is greater than or equal to 0. And let's see here, 150 grams used for cake A and 75 grams used for cake B, right? You only have 2,250 grams available. So whatever combination of cakes you bake, you cannot exceed the limitation of your amount of flour that is available to you. And this would be discrete as well. Okay. Bakery can make no more than a total of 600 muffins and bagels in one morning. X would be number of muffins. Y would be number of bagels. X, Y greater than or equal to 0. X plus Y is less than or equal to 600. So in that case, no like the coefficient is 1 for both of them, right? Oops. One type of shelf requires 2 brackets. Another requires 3 brackets. A total of 42 brackets are available. 42 brackets are available to put up shelves. I'm just going to, I want to make sure I finish this before the bell. Let me see. Oh yeah, we're doing good. We're doing good. This would be number shelf type A shelf, type B shelf. Whatever you did here, you're fine. Both of them have to be positive. And then it's just, if we need 2 for the first type and 3 for the second, so this is just a fact, that has to stay smaller, right? Less than or equal to 42. Next, the owner of a sports store orders downhill skis for 200, cross-country skis for 150. The order cannot exceed $6,200. I think at this point, number of downhill, number of cross, and so that's xy is greater than or equal to 0. If it's $200 per downhill skis and 150 per cross-country skis, that has to be less than or equal to 6,200. I wish I had had a few more examples where it's pointed the other way, because it could have read, store owner has at least $6,200 available. So then you could have actually pointed it the other way, where you can spend more than that if required. However, I'm going to ask you to do this, okay? Please try this. We don't have much time. So homework is 44 to 45. I will post the key. This is writing inequalities, and it's a bit more challenging. I'm not going to lie to you. But you need to have tried it first, okay? So be ready for a short AC with just writing inequalities. And then we'll go over the homework a little bit and continue our journey with graphing, okay? We're going to graph these things. Thank you, guys.